Hello and welcome to DevOps Tools for Java developers. My name's Stephen Chen. I run the developer relations team at JFrog, longtime member of the Java community, and very happy to be talking about a topic which is near and dear to my heart. Now, I think most of you last year when this pandemic first broke out, first of all, you probably wouldn't think that you'd be attending Devnexus virtually this year. Last year it was awesome to be able to meet everyone in person in Atlanta, but also I don't know how you guys felt about it, but I somehow pictured that it would be a lot cooler than it actually turned out. So this is how I figured that I would end up during the pandemic, maybe walking down the highway with my trusty dog, fighting off bandits, searching for food. But this isn't actually how the pandemic turned out for most of us. And what actually happened was all of us technology geeks, fortunately, were able to continue working from home, kept adding more monitors, fancier chairs and keyboards and mice. In the case of me, a lot more microphones and cameras and whatnot. And we're fortunate that we're able to continue to work from home, be productive, and kind of weather the storm. And I think it's great that technology professionals are able to do this. And with that also comes some horrible decisions as well. And given the extra time and bandwidth, I went ahead and started to write a book again. So one of the books which I'm working on currently for Riley is DevOps Tools for Java developers. It's kind of a end-to-end view of everything which you need to know as a Java developer to be an expert in doing your build automation, doing continuous delivery, turning into a hyper-performing DevOps team. This presentation you can find online at the link you see there. Also, there's a landing page there to enter a raffle. So my employer JFrog is generously giving out probably the coolest Lego set in quite a while, a baby Yoda Lego set. So just scan the code there to go to the website or type in the URL below. And that also has the slides and all the content for this talk, so no need to take notes while we're going through the content. And the topics we're going to cover today are how to handle source code, so how to structure your, how to get a single source of truth, continuous integration, building and testing on every check-in, package management so that you can manage your binaries, have a full bill of materials and history for traceability, doing security scanning of dependencies and containers being pushed to production, and finally continuous delivery for distributed automated deployment to the edge and beyond. And to start out, let's dig in on I think everybody, a topic which every developer kind of begins with, which is how do you get the right source control system and team collaboration to support your project needs? And I think if you look at the evolution of version control systems, we really started with some very primitive tools, which went all the way back to simple things like emailing files around, or even before email, sharing files on shared file control systems. We eventually came up with proper version control systems, the first generation of which were locking version control systems. So if you're old enough to remember this, don't raise your hand too high, or everyone will know exactly how old you are. But systems like SCCS and RCS allowed you to do this on Unix systems, and this was kind of the first attempt at doing collaboration without stepping on each other. Now, if you're only locking at a file level, the challenge with that, especially when you have a large project, is dependencies aren't limited to just files. So you might be changing an API and you have to change all the code which is related to that. And therefore, what you'd like to do is you'd like to be able to make changes across the system without locking every single file in your project. And this is where the second generation of systems came in with open source projects like CVS and Subversion, which allowed you to go ahead, make changes to a whole bunch of files, not worry about actually locking the files or preventing other people from making changes to the same files, and dealing with the conflicts later as merge resolution. So this is perhaps the greatest advance in version control systems, but also the greatest bane to all of us, because now we spend an inordinate amount of time either resolving merge conflicts or figuring out how to avoid producing merge conflicts with better team organization. And the latest generation of version control systems are distributed version control systems. And the concept here is, why do you need a centralized version control system? Now everybody can have a full copy of the version control system locally. You can work entirely offline. You can even synchronize change lists directly with people without going through a central server, although in practice, most folks have a kind of a single source of truth for their version control, which is stored in a central Git or Mercurial repo. And the two most popular version control systems for this are Git and Mercurial, although over time, Git has clearly won out and is the version control system of choice. So if you are still using CVS, my apologies, time to upgrade and stop having your repository corrupted every few days. If you made the move to Subversion, that was a huge upgrade over CVS, but again, I think this isn't really the path forward. And in the past 10 years or so, everybody has basically migrated over to Git and distributed version control systems. And if you look at the way distributed version control systems work, basically the standard practice is you have a local repository, which is a full repository, so it has everything locally. It also has a working copy of the code, and the working copy of the code is what you're modifying. You then check into a local copy. So in the concurrent or the centralized version control system, that repository will be stored in a remote server, and every time you committed or merged, you'd have to pull back changes across the network. This allows you to do everything locally until you're ready to push or pull code from a remote repository. And the standard way of doing this is having a server which holds the remote repository, and then pushing and pulling changes to, or making pull requests and having somebody manage and integrate all those changes. So this is really the way forward and what everyone's doing. One side note on this, when we get to binaries and package management, is that this also drove another revolution in VCS, which was don't store your binaries, don't store big blobs of data or dependencies in version control, because then you end up with unwieldy large local repositories. So when we get to package management, this is one of the things which drove that revolution as well. And you can see from the Stack Overflow survey this year that there's a bunch of different tools that you can use to manage your Git repos remotely. The most popular of which is GitHub. So this is used for most open source projects as a collaboration tool, as a way of managing pull requests, as a way of getting more folks involved in your project. And GitLab is another commercial VCS system. You also have Microsoft Teams for folks who are on .NET platforms, and a whole bunch of different solutions for team collaboration like Slack and Jira and Confluence, which are all things which we use on a daily basis. But you can see that version control systems and tools have definitely pushed the top of developer tools, which we all care about. And a common pattern for how you manage all of your branches and your merge strategy when you're using Git is called Git flow. So this was kind of the great granddaddy of all the different strategies for how you can organize your repositories. It is both the most complete, but also probably unnecessary overkill for most projects. There's a lot of branches to manage with a develop branch, a release branch, a hotfix branch. So you have way too many branches which you have to manage simultaneously. And it's really most suitable for software which is released with versions, where you have to do patches against previous versions, and you have to maintain patches against multiple versions of a code base simultaneously. If you're doing any sort of web-based or server-side software, you really don't need to worry about this, because there's always kind of one latest version which you're updating, you're maintaining, and you're patching, and you don't, quote, have an old release which you have to patch separately. So it makes the the management of branches and patches much easier to do. But the basics of Git flow are kind of underlie the rest of the change management strategies, which I'm going to talk about, because this is the concept of folks making changes in feature branches, then pushing them back into a develop branch, or making a pull request and have somebody pull it into a development branch, and then using that development branch as kind of your main code line, which is supposed to always build and be a stable code line for folks to pull from and to continue to make changes. And this feature branch style of development really works well for teams, and it avoids a lot of the merge conflicts and issues which folks have had with managing version control systems. So the key properties of Git flow are: you have a development branch, a branch per feature. You're not using fancy features like fast forward merges or rebasing, and you typically keep a separate release branch. GitHub came up with a much simpler model, which is coined GitHub Flow, which gets rid of the need of having release branches. So this makes it much easier since you're managing fewer branches. It still doesn't use fast forward merges and rebasing, so it ends up with a history, which is a little bit more complicated to look back at if you want to look at changes. But it also avoids the possibility of rewriting history causing issues with conflicts on the server. GitLab Flow is an evolution of GitHub Flow. It's similar in that it doesn't use release branches, has one branch per feature, but embraces things like rebasing history. So if you rebase your history before you make a check-in, what you can do is you can keep your history in Git to be kind of a single linear flow, which is sometimes easier to read. And also the merge strategy allows for things like fast forward merges, which again reduces the complexity of branching. Now, that said, you have to be careful when you're doing rebasing and merging, because if you push any changes before you actually we try to rebase, then you can cause issues with folks who are relying upon history, which you've then rewritten, and that causes all sorts of havoc in the backend Git system. So I hope that by now you guys know enough, or already using Git, have chosen a branching strategy, have your team workflow worked out, and kind of the next big step for teams is figuring out how to do continuous integration, running all of your tests, and making sure that you are having builds and test and QA in multiple stages. And typically the way this would look at is you check your code into source control, and every check-in you have some sort of hook set up. There's a CI server set up, which will, when it sees that there's a change, we'll pull a version of the code, we'll run it, and we'll push into an integration system where you might run integration tests. If the quality controls and all the tests pass, then you might move it over to a system testing environment. Again, you'd have some quality thresholds, acceptance tests, or different things, and then it would be pushed into a staging environment. And then finally, if you're able to verify the features meet the business requirements and have folks test and make sure that it's exactly what you want to push into production, then push it into a production environment. And this kind of incremental set of quality gates is extremely important, because what it prevents is things like what happened to our friends at Knight Capital. So Knight Capital is kind of one of the classic fails in the software industry, where they're a company which specialized in building systems for trading applications. And when you're in the financial industry, it's extremely important that your systems are stable and reliable, and you're not introducing any regressions into production. On the deployment of a new system, when they were introducing a new trading option, Knight Capital ran into an issue where the system was executing trades by itself erroneously, causing 10 million trades per minute to be executed. And at the speed which financial transactions happen, and the cost of financial transactions, over the course of about 30 minutes, which it took them to diagnose and figure out what happened, this was $440 million lost. And there were 154 different stocks involved, which were traded and kind of caused complete havoc in the market as a result. And when you get down to the root cause of what actually happened with their system, this turned out to be an issue with how they deployed code, and they deployed the code to they had a cluster of 8 servers. When they went from staging to production, they didn't have an automated system for this. It was a manual system for pushing changes to production, and 7 of the 8 systems were updated successfully. 1 of the 8 systems wasn't updated successfully, and there was a API change in the system, which wasn't very obvious. It was an old API that was being reused, which again is another anti-pattern. And what happened is when any of the trades hit the one server, which was not updated, it would use some old APIs and then would execute erroneous trades. Their first attempt to fix this was to roll back the changes. And since all the clients weren't rolled back, it was just the servers which were rolled back. What happened then is that all 8 servers were executing erroneous trades. And then they lost even more money. So eventually they figured it out and they staved this off. But it basically caused the company a huge financial loss. And eventually they were acquired into another company when all the dust settled and all the damages were collected. So going to the next topic, we're going to skip over package management. We're going to come back to that. But I think security scanning is an area which is extremely important. And this is, again, another thing which can mean the difference between a successful business and one which has extreme challenges and problems. And in the software world, if you wanted to do a parallel of this, security vulnerabilities have basically become the new oil spills, which can cause dramatic and catastrophic damage if you're not careful about mitigating them. So the analogy here would be this is a classic oil spill problem. So Taylor Energy back in 2004 was hit by Hurricane Ivan and was leaking 300 to 700 barrels per day. And due to the damage of the hurricane, it cost $435 million in cleanup. They finally figured out a solution to this just recently. And if you look at open source software, we all run open source software. Open source software is in 99% of enterprise projects, and 75% of those projects contain at least one vulnerability, with about 82 vulnerabilities per code base average. So if you think you're excluded from having potential security vulnerabilities in production, as long as you're using open source software, you're definitely not. And even the software you write yourself is susceptible to security vulnerabilities, which can cause damage almost equal to an oil spill. For example, what happened to Equifax and their data breach, which is kind of the classic fail in the software industry, where there was a vulnerability in Apache struts, CV 2017-5638, and this allowed attackers to get into Equifax's databases via an unsecured server. Once they got into the internal systems, they were able to tunnel into other systems and actually get access to consumer data. They had access to systems from March through July of 2017, and this cost Equifax $1.4 billion in cleanup costs and $1.38 billion in consumer claims, affecting 143 million consumers. So this is what happens if you don't pay attention to security issues. And eventually this was attributed to the Chinese-backed military. So February of last year, they finally indicted the Chinese military for being the ones behind the attack. And actually, this is probably a good thing because so far none of the consumer data actually was exploited from Equifax. It was just consumer claims which were worried about data being leaked. So getting back to our oil spill problem, if you're not paying attention to security vulnerabilities, you could be the next Equifax or the next oil spill. And fortunately, but in both cases, we now have technologies which can help us to solve these problems. For the Taylor Energy oil spill, they built an oil containment system, which they retrofit, which collects the oil and pumps it up to ships that now collect it and resell the oil coming from that. So they brought the flow rate down to about 1,000 gallons per day, and they use a 200-ton steel box on top of this system to contain the oil. 3 to 5 gallons per day once they've contained the oil. And for security vulnerabilities, you can now use security scanning tools like JFrog X-Ray, which allows you to scan binaries. You can use other systems upstream to scan your code base. And there's new systems coming out which do runtime vulnerability scanning. So the next phase in your DevOps pipeline is continuous delivery, doing distributed and automated deployment to the edge and beyond. And the reason why this matters so much is because we're all using devices like smart cars, smart TVs, cell phones, and even smart fridges, which need a continuous supply of software updates to allow you to use your devices and enjoy the latest features. So you need this both for new feature delivery and also for patching vulnerabilities. And usually as a consumer, when you're looking at do I want to update to the latest version of software, the thought process is, here's a new update. Do you want the update? So hopefully the answer is yes. There's actually some cool features that you want in it. Is it risky? Well, if it's not risky, you'd probably update, but it might be risky and you might not trust it. So then you'd have to verify it. And if you have to verify the software release, this often is a costly verification before you make the update, which can cause consumers or software developers to not update to new libraries. And a classic example of this is the new JDK release model starting in Java 9 with modularity, which was announced at Devoxx Belgium 2017. So this is kind of what the new reality for all us Java developers, where we get 6-month release cycles. We have a continual stream of releases coming out with LTS releases and incremental releases. And there was also a big shift with Java 9 where modularity was not entirely backwards compatible and broke a bunch of things in systems and libraries which we all depend upon. Subsequent releases have been a lot less dramatic in terms of the change, but also the system for deprecating features has also been changed, where now deprecated features can be released in any of these releases as well. So if you look at this from an adoption standpoint, for folks in the chat, if you don't mind, let us know what Java release you're current running. And I think basically for most software developers, this kind of falls into 3 categories. Either you're still stuck on Java 8 for some reason because you can't upgrade, or you choose not to upgrade. You made it past the Java 9 threshold and you're on a nice LTS release like Java 11. Or maybe you're on the latest release of Java, so you're running Java 14. So earlier this year, there was a great study done by Sneak on the Java community, and what they did is they polled also what all the software developers were using, and their data showed that 64% of folks were still on Java 8, 11% of folks made it, or 25% of folks made it to Java 11, and 4% of folks were on the latest release of Java, which at the time was Java 12 last year when the study ran. And if you kind of go back to our flow of why this happens. So as a Java developer, this is kind of the flow which you probably ended up going through. So the first question is, a Java update's available. Do you want it? Hopefully you want it. Some folks actually don't want modularity, but assuming you want it, the next question, is it risky? So in the case of modularity, we know there's backwards compatibility issues. So yes, it is risky. Do we trust it? Probably not. So then you have to verify it. And if you're going ahead and trying to verify something like a major JDK upgrade, we all know that this is quite a large undertaking. And I think this also is the reason why a lot of folks have chosen to skip or defer updates, because either they don't really need features which came out in Java 9 and beyond yet, or they haven't been pushed to adopt. And the verification process to update to Java 9 Plus also is quite a lot of work. And when you don't have a good process for doing continuous delivery, what can happen to you is what happened to another company which we all rely upon for updates, which is Cloudflare. So you want to be releasing continuously, both for features and also because you want to avoid security risks. And having an automated system and having a way to do this, which is repeatable, is highly important. So in Cloudflare's case, they had a huge outage, which was caused by an update to a fairly innocuous regular expression. And for all the experts in the audience who are pros at regular expressions, what do you see that's potentially wrong in this regular expression if you're trying to run it on a large set of data? Okay, so this like anything else, this is kind of one of those tricky problems. And the interesting part of the regular expression is highlighted here in red. So the dot star question call and dot star equals dot star. As you guys know, there's a capture group. The parenthesis question call is a capture group, so you can safely ignore that. And what it simplifies down to is a dot star equals dot star. And what you're doing is you're doing a double wildcard capture. And what happens in a lot of regular expression engines is when you have a double wildcard on a very, very long search string, which happens when you have large data sets going through, then this essentially becomes an exponentially costly query to run. And this caused the entire Cloudflare system to go down as a result of that. So if you caught and figured this out, give yourself a big pat on the back for being a regular expression genius. For the rest of us who didn't notice it, you're just a mere mortal, and you would make the same fix if you didn't have the right automation and processes to do continuous delivery. So the last topic I'm going to cover is package management. And I think if you look at this spectrum, what ties everything together, source control systems, continuous integration, security scanning, and continuous delivery, is you on all those systems, you're either building or consuming a binary, whether it's a Docker image or whether it's a module like a Java module, a Node module, or something else. And if you want to be successful with having a centralized repository like this, it really has to support all the different formats and possibilities, kind of be the Switzerland of different continuous integration systems, different binary formats. And this is exactly what we do at JFrog with Artifactory, which supports just about every tool in the industry for build tools, dependency management, remote repository, CI servers, provisioning tools. We integrate with just about everything and serve as a central repository and understand natively how to pull apart jars, how to pull apart Docker images, how to serve as a container registry. So this is kind of the crux of your overall system. So this was a quick lightning talk through the world of DevOps from the eyes of a Java developer. I hope you learned a little bit more, and the book which we're working on, DevOps Tools for Java Developers, will be released later this year, but we already have a preview available if you're interested in that. Again, you can enter to win a Baby Yoda Lego set, which is awesome if you follow the link. And I'm more than happy to answer questions for folks who have them. So thanks very much for coming to my talk at Devnexus. And I hope you enjoy the rest of the conference. And then I'll be able to see you in person next year when we're all back to normality. So thank you very much.